Okay guys, today what we're going to do is we're going to learn about completing the square. This is where we take a quadratic function and we're going to rewrite it. We're going to rewrite it in this form right here. A constant, which I call a, times x minus h squared, again h is a constant, plus k. And k is also a constant. So a, h, and k are all constants. So we're going to take quadratic trinomials, that's what we're going to have. We have our three functions over here. And we're going to rewrite them in this form. And then once they're rewritten in that form, we're going to answer these questions, right? So the first thing we're going to do is complete the square. That means that we're going to write it in this form. That's what it means to complete the square. Then we're going to find the vertex. So we know that quadratic functions of this nature, they graph a parabola. And so a parabola will either have a maximum point or a minimum point. We call that the vertex. The vertex of a parabola, believe it or not, is hk from this formula right here. So if I take my quadratic trinomial and I put it in this form, then whatever value I have here for h and whatever value I have here for k, this is my xy coordinate for my vertex. It's one of the reasons that we put the quadratic trinomial in a complete the square form, in this form, is so that we can find the vertex. So we're going to find the vertex, then we're going to state the axis of symmetry. Again, the idea here is that because it's a parabola is symmetric about its axis, and so if we can find the vertex, we can find the axis, right? So we can find the axis of symmetry from the vertex. And then finally, we're going to find the roots. So we're going to find the roots of the function. That is to say, we're going to find the points at which the function crosses the x-axis. That's what we're going to do. All right, so let's get to it. So I have three functions. My first one is x squared plus 2x minus 6. X squared plus 2x minus 6. And I want to complete the square. So I want to take this quadratic trinomial and I want to put it in this form. Here's how we do that. I'm going to rewrite it as, I'm going to put parentheses here, x squared plus 2x. I'm going to put my other parentheses here. I'm going to purposely leave a gap. We're going to have minus 6. To complete the square, what we do is the following. We look at this coefficient on the x term. In this case, it's 2. We have it, square it, and then add it on. Say it again. We look at the coefficient that's on our x term. In this case, it's the number 2. We have it. Well, half of 2 is 1. We square it. 1 squared is 1. And then we add it on here. That's what I have this little gap for. So I add on plus 1. So this plus 1. So again, I take my coefficient. I've halved it. 1 squared is 1. And I've added it on plus 1. Of course, I can't just simply add a plus 1 to my original function without changing it. And so in order to make sure that everything is okay, I have to now subtract 1. And I'm going to do that over here. I'm going to subtract 1 over here. Okay, what have I gained? Well, if you've done this properly, and I think I have, what you have here now inside my parentheses is what we call a perfect square trinomial, which means that x squared plus 2x plus 1, if I think about this for a second, I should realize that this is really nothing more than x plus 1 squared. Inside the parentheses here, I simply have x plus 1 squared. And you can go through the algebra of that yourself if you want. You can take x plus 1, multiply it by x plus 1, and you'll find that when you FOIL it out that you get x squared plus 2x plus 1. And so I have here what we call a perfect square trinomial. And as I say, if you've done this correctly, you will always have inside your parentheses here a perfect square trinomial. I have here minus 6. Minus 1, well, minus 6 minus 1, that's minus 7. And that's it. I am now in the form I want right here. I'm now in the form of some constant a, in this case my a is 1, times x plus 1 squared, that's my x minus a squared, plus a constant, minus 7. I have now completed the square. Okay. Can I now find the vertex, for example? The answer is yes. Now I need to be careful. There is a minus here in my original formula, whereas here I have a plus. So if you like, this is really x minus negative 1 squared minus 7. So just be careful. So my h term here in this function is not 1, but because I have here a minus, my h value is actually minus 1. So my h value is actually minus 1. My k value up here, well, here I have a plus, so it's okay. So I have a minus 7. And so my k value is negative 7. And what this means is that the vertex of this function occurs at a point minus 1, minus 7. Minus 1, comma, minus 7. Those are the x and y coordinates of the vertex of this parabola. And so, do a very quick sketch. Perhaps here's minus 1, here's minus 7. The vertex occurs right here. So my parabola, come down, etc. I'll have a parabola like so. Now, the axis of symmetry, well, like I say, a parabola is always symmetric about a central axis. And if this here is the vertex of my parabola, well, the axis of symmetry goes through the vertex. It's a vertical line that goes through the vertex. And so my axis of symmetry actually goes through here. Right? It goes through that vertex of minus 1, minus 7. And so this line here is the line x equals negative 1. And that is my axis of symmetry. So my axis of symmetry is the line x equals negative 1. For a parabola written in this form of a quadratic in this way, you will always have your axis of symmetry will always be a vertical line. It's going to be a vertical line that goes through the x-axis. Okay, so that's the first 3 parts done. I've completed the square, that's here. I found the vertex, minus 1, minus 7, and I have found the axis of symmetry. The axis of symmetry is the line x equals minus 1. All right, so all that remains then is to find the roots. So to find the roots, we say the roots are points at which the function goes through the x-axis, otherwise known as the x-intercepts. So what I'm going to do is I'm going to let my function equal to 0. I'm going to let my function equal to 0. Well, since I'm already in this form right here, I've already completed the square, I'm going to let my function here, let this x plus 1 squared minus 7 equal to 0. Like I said, remember, we let our function equal to 0 in order to find the roots, in order to find the solutions, the x-intercepts, whatever you want to call them. All right, well, if x plus 1 squared minus 7 is equal to 0, what I really have to do is just solve this equation now. First thing I'm going to do is I'm going to bring my 7 to the other side. And so I get x plus 1 squared is equal to 7. All right. I have a square on this side, so what I'm going to do is I'm going to take the square root of both sides. The square root of x plus 1 squared is simply x plus 1. And the square root of 7 is plus or minus the square root of 7. So the square root of 7 is just the square root of 7 plus or minus because I'm taking a square root. And so now, to solve for x, all I have to do is subtract 1 from both sides. So I get x is equal to minus 1, and I have plus or minus the square root of 7. And that's my answer. So I have 2 solutions. It crosses the x-axis at 2 points. One is, call it x1 maybe, minus 1 plus root 7. And my second root, I'll call it x2, is minus 1 minus root 7. If you wish, take out your calculator, find the value of root 7, take minus 1 plus that value, minus 1 minus that value. Those are the actual coordinates of the roots, and that's your answer. So we have found then the roots of the function. These are the two values. And that's it. All right, so that's that first problem completed. Let's do another one. So my second problem is another trinomial. Take this as well. It's x squared minus 6x minus 6x minus 16. Okay, so this is my function. Same thing, I'm going to, first off, I'm going to complete the square. So the way I'm going to do that is I'm going to rewrite this as x squared minus 6x. I'm going to leave a space here. I have minus 16. In here, what I'm going to do is what I did last time. I'm going to look at the coefficient on my x term. Here, this time it's minus 6. I'm going to take half of that value. Well, half of minus 6 is minus 3. Square it. Minus 3 squared is 9. And add it on. So that is plus 9. Of course, if I add 9 here, I must subtract 9 over here to make sure I don't change my function. And again, if I've done this correctly, what I have inside the parentheses now is a perfect square trinomial. X squared minus 6x plus 9 is really just x minus 3 squared. X minus 3 squared. You take x minus 3, multiply by x minus 3, FOIL that out, and you will get x squared minus 6x plus 9. Minus 16 minus 9 is minus 25. And that's it. I've completed the square. That's all I have to do. Again, I'm in this form over here where my a value is 1. My h value this time, looking at this formula up here, this time I have a minus in my function, I have a minus here. Okay, so my h value is simply therefore 3. Right? It's not minus 3 this time. So last time I had a plus here, so it was a minus times a minus that would give me that plus. Here I already have a minus. So my h value is simply 3. And my k value is negative 25. And this value, 3 and negative 25, that's the vertex. So the vertex of my parabola occurs as 3, comma, negative 25. And again, what this means, because it's a parabola, I have an axis of symmetry that goes through this point, the point 3, negative 25. The axis of symmetry is a vertical line that goes through the, that has a value of x equals 3. So my axis of symmetry, right, my parabola perhaps looks something like this. Here I have 3. Down here I might have negative 25. So this here is the point negative 3, negative 25. And my parabola comes down. This is its minimal value and then comes back up. Again, notice that I know it opens upwards because the coefficient on my x squared term is positive, so I know it opens upwards. And so my axis of symmetry then is this line right here. It's a vertical line that goes through the vertex. And that is, this line here is the line x equals 3. So my axis of symmetry is simply x equals 3. It's that line right there. Okay, so that's the first 3 parts of it complete. Let me now just take the final part and let me solve for the roots. So the roots of the function in order to find the roots, I'm going to let my function here equal to 0. That's how we find the roots. So I'm going to let x minus 3 squared minus 25, I'm going to let that equal to 0. And I'm going to solve this. Okay, I'm going to add 25 to both sides, so we get x minus 3 squared is equal to 25. And now I'm going to take the square root of both sides. So I get that x minus 3 is equal to plus or minus, the square root of 25 is 5. So it's plus or minus 5. And now, to solve for x, I'm going to simply add 3 to both sides. So I get that x is equal to 3 plus or minus 5. So x1, if you like, x1 is 3 plus 5, that's 8. And x2 is 3 minus 5, that's negative 2. And so these are the two x coordinates of the roots. And so the function, my parabola, crosses the x-axis like at minus 2, 0, and 8, 0. Those are the 2 points at which the function crosses the x-axis, otherwise known as the roots of the function. Okay, 2 done, 1 to go. So, my third and last function is 2x squared plus 4x minus 7. All right, so this time the difference is my leading coefficient is no longer 1. My leading coefficient here is 2. So here's what we need to do. In order to get it into this form, the first thing I'm going to do is I'm going to factor out whatever the coefficient is on the x squared term out of the first 2 terms. I'm just going to take it out of the first 2 terms. So the leading coefficient is 2. So I'm going to factor out a 2 out of this term and a 2 out of this term. That will give me 2 on x squared plus, if I factor out a 2 out of here, I'm left with 2x. I'll close my parentheses and I have a minus 7 over here. So that's the first thing I'm going to do. I'm now going to just focus on what I did last time. I'm going to just focus on this part here. So that gives me 2 on x squared plus 2x minus 7. And now I'm going to complete the square right here. Well, again, I look at the coefficient on my x term. This is 2. I take half of it. Half of 2 is 1. Square it. 1 squared is 1. Add it on. Plus 1. And now this is just where you need to be careful. You might be tempted to subtract 1 here from the negative 7 because I added 1 here. However, there is a leading term here of 2. And this 2 multiplies to every term inside these parentheses. This is 2 on everything inside these parentheses. And so this 1 is really 2 times 1, which is 2. And so when I add a plus 1 here, I'm really adding 2 overall to the function. And so I must subtract 2 right here. I must remember to subtract 2 right here. That's the difference when you don't have a leading coefficient of 1. Just remember to always catch that detail. Everything else is now just the same. I have a 2 times x squared plus 2x plus 1. This is again a perfect square trinomial. This is really just x plus 1 squared. Minus 7 minus 2 is minus 9. And note, I have completed the square. I am now in this form. My a value this time, my leading constant here is no longer 1, it's 2. That's okay. So my a value is 2 from this formula. My h, again, it's a minus here. So if I have a plus here, this must be x minus minus 1. And so my h value is minus 1. And finally, my k value is negative 9. The hk, that's my vertex. My vertex is minus 1, minus 9. Minus 1, comma, minus 9. That's my vertex. And as before, the axis of symmetry will go through this point, through the vertex. This is maybe minus 1, this here is minus 9. So minus 1 minus 9 will be here, for example. And my parabola, come down, whatever it looks like, will go through, that'll be its middle value, and then it will go back up. It will be symmetric, and the grid is symmetric. Symmetric about a line through there. This is the line x equals minus 1. So this here is the line x equals minus 1. And that is my axis of symmetry. That is that third point. Find the axis of symmetry. The axis of symmetry is x equals minus 1. Okay, finally, we want to, having found the vertex, having found the axis of symmetry, we just want to find the roots. In order to do that, we're going to take our function in this form and we're going to let it equal to 0. So I'm going to let, just draw a line, I'm going to let my function, which is in completed square form, which is 2 on x plus 1 squared minus 9, I'm going to let that equal to 0. Let it equal to 0 in order to find the roots. Okay, solving this, that gives me 2 on x plus 1 squared 9, adding 9 to both sides. I'm going to divide both sides by 2, because I have a leading coefficient of 2. So I'm going to say that this is x plus 1 squared is therefore equal to 9 over 2. I'm dividing both sides by 2. And I'm going to take the square root. So that will give me x plus 1, square root of x plus 1 squared x plus 1 is equal to the square root of 9 over 2. The square root of 9 over 2 is plus or minus. The square root of 9 is 3. And the square root of 2 is root 2. And so I have x plus 1 is equal to plus or minus 3 over the square root of 2. The square root of 9 over 2 is plus or minus 3 over root 2. To get x, I'm going to simply subtract 1 from both sides. So I get x equals minus 1 plus or minus 3 over the square root of 2. So x is equal to minus 1 plus or minus 3 over the square root of 2. So I have two values. Let's put it here. One value, one root is x minus 1 plus 3 over root 2. And x2 is minus 1 minus 3 over root 2. Like I say, the roots are the values for which the function crosses the x-axis. So as an ordered pair, it would be comma minus 1 plus 3 root 2 comma 0. That would be one coordinate. And the other one is minus 1 minus 3 root 2 comma 0. Those are my two values. And that's it. I have answered all parts of the function. I've gone through 3 problems. This is how we complete the square. This is how it's done.